All right, in the next example, I'm going to do square root property again, but this time I'm not going to isolate that x squared term. That would, for this example, I'd have to FOIL it out, and I'm adding extra steps there. So to avoid that, I can actually see this is a perfect square on the left and a perfect square on the right. So it lends itself nicely to just taking the square root right from the start. So I'm going to go ahead and do this one on purple. So it's perfect, the square root on the left. And I'm still going to do the plus or minus the square root. So I have something squared. And when I solve for it, it's plus or minus whatever that side. So then I get x, oh sorry, this thing is squared. So the square root cancels the square. I get x minus 3 on the left. And on the right, I get plus or minus 25 is 5 squared. So that square and square root, the square root of 25 is 5. There we go. So I have two possible solutions here. I'm actually going to break this up because I have a plus and a minus here. So I have x minus 3 equals 5, or x minus 3 equals negative 5. On the left side, I can add 3 to both sides and get that x equals 8. And on the right side, I can add 3 to both sides again and find that x equals negative 2. So my solution set is a negative 2 and an 8. It's also correct to write it as 8, negative 2. I just tend to write ascending order for no particular reason. Again, with set notation, the order doesn't matter. It's just a list of possible candidates that when I plug it into that equation, it makes it true. So if I plug in that 8 for x, I like to check in green, so I'm going to go ahead and do that. Whoops, I like the light green. So I'm going to do a little check here. If I plug in the 8 for x, I get 8 minus 3 squared, which is 5 squared, which equals 25. And that equation is now true. Or if I plugged in the negative 2, I get negative 2 minus 3 squared, which is negative 5 squared, which also equals 25. And both those solutions make that equation true. So that's my solution set, checked. Let's do another example where we get a complex number. So let's do that one in blue. So what if I had, I don't know, x plus 2 squared equals 9. So this will be example 5. Okay, then I can, following that same process, take the square root of both sides. On the left, I get x plus 2. On the right, I get plus or minus 3. And then that is really two equations, so I'm going to break that into x plus 2 equals positive 3, or x plus 2 equals negative 3. And then subtracting 2 from both sides, I get x equals 1, or x equals negative 5. And my solution set is negative 5 and 1. So theoretically, I should be able to plug both those answers into here and get true results. So if I plug in the negative 5 for x, I get negative 5 plus 2 squared, which is negative 3 squared, which is 9. Oh, I messed up. I was supposed to do a complex. Okay, let's finish what we started here. Which is true, correct. That's checked. And if I plug in the 1, I get 1 plus 2 squared equals 3 squared, which equals 9 also. So both these solutions make that equation true. So that's my solution set. All right, let's do another example. Example 6, because I wanted to do a complex one. So I'm just going to do that same example, except make it complex by making this a negative 9. So now I have a square equals negative, which tells me I'm going to have an I in there. So when I go to take the square root of both sides, then on the left, I get the square and the square root cancel, and I get x plus 2. But on the right, The square of the negative gives me I, and the square of the 9 gives me a 3. I'm actually going to write that as 3i, because that's traditional when you have an I to and a constant, not a radical. It's traditional to write it first. But just to break this down, I can jump straight to that answer because I'm comfortable with I. But to break that down a little bit, if this is the first time you're seeing it, that is the same thing as square root of 9 times negative 1, breaking apart that negative from the 9. And that's the same as square root of 9 times the square root of negative 1, which equals 3i. All right. So I got 3i, but I have plus and minus, sorry. Always plus and minus when I take the square root. So I got x plus 2 equals positive 3i, or x plus 2 equals negative 3i. And that gives me, subtracting 2 from both sides, I get x equals 3i minus 2, or x, subtracting 2 from both sides again, equals, x equals negative 3i minus 2. There's a couple different ways to express that. You can express it as plus minus 3i minus 2, or you can express it as the solution set negative 3i minus 2 comma 3i minus 2. The 3i minus 2, I cannot simplify that anymore because they're not like terms. One of them has that I on it, one of them doesn't. So that's as simple as I can get with that complex number. All right, so that's my final solution on this one. And that is going to wrap up the square root property for us.